So our last example in this section has to do with calculating the required sample size. So far we've talked about how we create a confidence interval. What happens if we want to know, the sample size that we need? So it says if a researcher wants to maintain a specified confidence level and a specified margin of error, there is a formula that allows you to solve for the required sample size. And you would do this so that way when you collect your data, right, you have a large enough sample size that it will produce the specified level of confidence and that specified margin of error. So example 6 says, suppose we want to be 95% confident that the sample mean price of a gallon of gasoline is within 0.25, right, or 25 cents of the true population mean for a gallon of gasoline. If the population standard deviation for the price of a gallon of gasoline is 50 cents, how many gas stations need to be included in the sample? Okay, so let's see what we have, right? 95% confidence, so C is 0.95. And then it says the sample mean is within, right, 25 cents. So 25 cents, right, it's not the sample mean, it's actually my error, right? My error is 0.25, right, within 25%, 25 cents of the true population mean. Now then it says the population standard deviation for the price of gasoline is 50 cents, so 0.50. So if you look at the formula, right, we have the population standard deviation, we have the error. What we need is our critical value. Now, 95% is one that you should know, but in case you don't, I'm just going to walk you through the steps of how you can find it again, how you can always find it. So again, if I draw my curve, right, 95% confidence, so maybe something like this, again, just sort of a general sketch. So this is 95, right, you're 95% confident. So we have to figure out what the tails are, right? So the tails, if I take 1 minus 0.95, so 0.05, you can do this in your calculator too. Divide that by 2, right, you get 0.025. So that's going to be what the tails are in. So we can do inverse norm of 0.025, 0, and 1. If you have one of the newer calculators, again, you can just say 95%, right? 0.95 is in the middle, but so second vars, go down to inverse norm. So my area, I'm going to do 0.025 because I'm going to do it to the left. Mean 0, 1, left, paste that. Right, and you find, right, your critical value, and I'm just going to write it as a positive value, is 1.96. And if you look at the table at the very, very beginning of our notes, you'll see that, right, that 95% we say that the critical value is 1.96. Okay, so we have all the necessary requirements, right, the values that we need to find the sample size. So I have 1.96. I have the population standard deviation is 0.5. And then the error is 0.25, and we're going to square this. Okay, so we have 1.96 times 0.5 divided by 0.25. I usually find what's in the parentheses first, and then I'm going to square that. Okay, so 15.3664. So we're taking a sample size, right? And this is, right, prices of gallons. So we're probably talking, right, how many gas stations need to be included in this sample. So we can't have 15.3664 of a gas station, right? Now, if I just use like my normal rounding rules, right, and round to the nearest whole number, we would say 15. However, in order to make sure we have enough information from our from the sample, from what we're sampling from the population, we need to make sure we have at least, right, that 0.3664. So what happens is when we're calculating the required sample size, we always round up to the next nearest whole number. Doesn't matter what the decimal is, always round up. So our sample size, we would actually say, is we would need at least, right, so we would need to sample at least, right, so 16 or more gas stations, right, and that would be at least, I forgot the 16 gas stations. So here, let me write it in here. At least 16 gas stations. So you could do more, but you definitely need to at least do this in order to make sure you have, right, that error of 0.25 and the confidence of 95%. Okay, so that's how we would calculate our required sample size.